Alright guys, welcome back to another video on the LeetCode's channel. I apologize for the last video and the annoying static that was going on. Anyways, we're going to be solving LeetCode number 347, another question on the NeetCode 150 list. This question is top k frequent elements, and essentially, given an array nums and an integer k, return the k most frequent elements, and it seems we can return it in any order. Okay, so let's take a look at example number 1. Now we can see that we have 3 ones, so we can map 1 to 3. We have 2 2s, map 2 to 2, and then 3 to 1. Okay, and now it wants the 2 most frequent elements. Okay, let's take a look at our mapping. So the 2 most frequent elements are both 1 and 2, so we can return 1 and 2 in any order. So either of these would work. Great. Now, another thing worth noting is that the length of the array is from 1 to 10 to the power 5, and k is in the range 1 to the number of unique elements in the array. Alright guys, so for the first solution, we will be using a hash map, and this algorithm actually takes O of nlog n time. So for the follow-up, which states that we should find a solution that takes O of n time, this solution will actually not work. Nevertheless, let's see how this can be done with a hash map. Alright, so the first step would be to create a hash map, which we can denote as frequency. Alright, so for now we just have an empty hash map, and we want to iterate through the array. So we have a for loop that first points to the first element in the list. 1, okay, 1 does not exist in the dictionary. Let's add it to the dictionary with count 1. Okay, then move the pointer over. 1 already exists in the dictionary, so let's just update its frequency. 1 exists once again, so it has frequency 3, 2 has frequency 2, and 3 has frequency 1. Alright, so this is what our hash map looks like. So after we have created the hash map, from here it's actually pretty simple, because all we have to do is we have to sort the pair, the key value pair of each of the values in the dictionary by their value. And then what we'll get is a list, which looks a little something like this. So what we'll get in the end is a sorted list like so, 3, 1, which corresponds to this element in the map, 2, 2, and then 1, 3, which corresponds to this element in the map. We'd like to keep an output array, we'll call it res, and res should be initialized, of course, as an empty array. And then what we'd like to do is we'd like to keep a while loop, which essentially points at the very last index in the list, and it adds each of the elements in the array according to their frequency. So in the first case, we have 1. And what we can do is we can just pop it after we have added it to the results array. So what we would have now is 1, and then the next element would be 2, and then the next element would be 3, given that k is equal to 3 in this case. If k were equal to 2, we would just not add the last element in the array. This is what we would have in the end. And that's essentially it for the hash map solution. Alright guys, now for the hash map coding solution. So the first thing that we're going to do is just create our empty results array, and then we're going to create our frequency map. Alright, and then what we would like to do, of course, is iterate through the nums array. So for num in nums, what we'd like to do is we'd like to check first if num is in frequency as a key, and we like to check if it's not in, because in this case we just want to say frequency at index num is equal to 0, and then we'd like to increase frequency at index num plus equals 1. Alright, and that'll take care of gathering the frequency for us. And then what we would like to do is we would like to create a new sorted array by frequencies containing the elements from num. So essentially what we do is we'd say sorted by frequency is equal to sorted, and then we'll grab the dictionary's values, so frequency dot items, and then we'd like to sort it by, so our key will be equal to a lambda expression, so lambda x x at index 1, and then we would not like to reverse the array, so this is all that we would have. Alrighty, now what we'd like to do is simply populate the result array, which we can do just by creating a comprehension, or in this case I'll just create a for I in range, and then we just want to go up to k because we want the k most frequent elements. So for I in range k, we'll say result.append, and to the result we'd like to append sorted by frequency at index I. And since this is a tuple, we would like to use the first element in this tuple. So the tuple is essentially a key valued tuple. So first element is the key, the second element is the value. Alrighty, so then we'd reference index 1, and then we have gotten the k most frequent elements. So what we'll do is return res, and then we can run this code. Sorry, made a quick mistake. It's index 0 because that's the key. Run code, and of course the solution is not that efficient, but we will fix that in the next coding solution. Alright guys, so for the next solution we're going to be doing something called bucket sort. Now the time complexity of this algorithm is O of n, and the space will be O of n as well. Okay, so the way that bucket sort works is essentially we create an array with these little buckets which correspond to the frequency. So the index of a bucket corresponds to its frequency. So each of these sublists are considered buckets. And now within these buckets, we want to add each of the numbers that correspond to a specific frequency. Now let's walk through an example of this. Okay, so consider the first example. So what we do is we look at the number of elements in the array because we want to figure out what is the maximum frequency that we can have, and of course it is the number of elements in the array. Okay, so the first thing that we'll do is we'll create an array with n plus 1 buckets, just because there's not going to be any elements with frequency 0, so that first one's going to be an empty bucket. So in this case we have 1, 2, 3, 4, 5, 6, so we'll have to have 7 buckets. Alright, so that's what the array will look like, and essentially what we'll do is we'll keep a frequency map like we did in the last solution, so we can call it frequency, right? And this map will just map the frequency of each of the elements in the list, or the element to the frequency of it in the list. So in this case, using the same algorithm as in the last solution, we'll just say 1 maps to frequency 3, 2 maps to frequency 2, 3 maps to frequency 1, and this is the frequency dictionary. Okay, Now, what we'd like to do is we'd like to iterate through the frequency dictionary, adding each of the elements into the index of their key. So essentially what we do is at index 3, we'd append 1. At index 1, we append 3. And then from here, what we'll do is we want to start building our output array. Well, to do that, what we can do is we can iterate through the array from the back. So essentially, what we'll do is we'll first look at this one, see if there are any elements. So create an array called result. We'll see if there are any elements in this, because this would be the most frequent. No, there's no elements. Okay. Are there any elements in this array? No. And then until we get to this array, once we find an element, what we'll do is we'll add it to the array. So then in this case, it would be 1. All right. Then the next thing that we'll do is we'll take a look at this array. So there is another element that we can add. Great. And then let's just say we're looking for frequency 2 as given in the example. This would just be our result. Now, what if we had another element here and we were looking for frequency 2? Well, what we could do is we could pop from this array, or we could take a list slice for the exact amount of elements that we need. So in this case, the result list would look something more like this, although this would also be valid. Now, once we've built a result array, we can just return, and this actually has time complexity of O of n, because all we're doing is we're first building this empty bucket list, which takes O of n time, because we're exactly filling the outer array with n plus 1 buckets. And then the next thing that we're doing is we're iterating through the nums array, and we're accumulating each element's frequency in the nums array, which is again about n steps. And then from there, what we want to do is we want to iterate through the map, which will be at most n steps. And then from there, we want to iterate through this frequency array that we have built of buckets containing elements with a given frequency. And this takes n steps to iterate. And what we'll notice is that you might ask, okay, well, what if a container just contains n elements? Well, what is important to note is that we're popping, or we're removing at most k elements, and k is always less than or equal to n, so we can say this is at most n steps. So this, building our result array, will be 2n steps, which is of course O of 2n. So in total, the algorithm is O of n time. Now for space, what did we use? We used a mapping. So let's just say every element had frequency 1. That's O of n space. Okay, and then we also built this buckets array. Well, that's also O of n space. That's taken. And then the results array, O of n at most. And that's it for the solution. Alright guys, and for the second coding solution using bucket sort, we will begin, of course, first by initializing our result array. So result is an empty array, and then the next thing that we'll do is we'll actually create our buckets. So bucket list will be equal to a list, and we'll use a comprehension in this case, each time adding a new bucket. So for underscore in range, and then since we want n plus 1 buckets, what we'll write is for n in range length of nums plus 1. So that'll create n plus 1 buckets where n is the size of nums. Alrighty, and now we'd like to actually figure out what the frequencies of each of the elements are so that we can populate the bucket list. Okay, so the first thing that we'll do is we'll create a frequency dictionary, empty at first, and then we will iterate through the nums list as we did in the previous question. So for num in nums, what we'll do is first we'll check if num is in. So we'll check if it's not in. frequencies, because in this case we actually need to initialize it. So frequencies at index num is equal to 0, and then we can just increment the frequencies. So frequency at index num plus equals 1. Alrighty, and then from here what we'd like to do is we would like to iterate through each of the frequencies in the frequencies mapping, and we would like to append them, the elements associated with specific frequencies, to that corresponding index in the bucket list. So what we'll do is we'll go for elements in frequencies. What we'll do is access, so we'll say bucket list at index frequency of an element. So at a certain frequency, we will append the element. Great. Alright, so now what we have is we have that list of buckets fully populated, and then from here what we'd like to do is we would like to iterate backwards through that list each time, updating our result list. Okay, for I in range, and we want to go backwards here, so from the last bucket, so length of nums over here, we want to go down to the 0th bucket, but it's -1 since it's not inclusive, and then we like to decrease by 1 each time. Great. And then from here what we'd like to do is we would just like to append buckets underscore list. Now we would like it to be the ith index, and specifically we would like to append from index 0 to k, and then each time what we're going to do is we're going to remove the number of elements that we have added. So here what we'll do is we will add this to results plus equals, and then from here we'll say that k is equal to, we would like the previous value of k minus the length of bucket list at index I. Now of course in the last iteration we might not use all of the elements in bucket list at index I, which is totally fine, because what we'll have here is that k will become negative. So when k becomes negative, what we can do here is say if k is less than or equal to 0, what we would like to do is just break, or in this case we can simply return the resulting array, and then we would be done. And that's essentially all that there is to it. Since we're guaranteed a solution, we essentially know that this loop is always going to reach this point where k is less than or equal to 0, so we can submit this now, and then we get the correct solution. And this one is in O of n time, and that is all. Thank you guys so much for watching, and another video is coming your way very, very soon.